This video is about using the equation of motion formulae for constant acceleration to model an object moving vertically under gravity. The force of gravity causes all objects to accelerate towards the Earth. If we ignore the effects of air resistance, this acceleration is constant. It does not depend on the mass of that object. So let's go through some definitions first. So kinematics is the study of the motion of objects without considering the forces which cause the motion. Gravity. In A maths, gravity is only used in the context of the Earth's gravity. Gravity is considered to be the force that the Earth exerts on all objects. It is an invisible force which pulls objects towards the Earth. Acceleration due to gravity, and that's the important part. If the only force acting on an object is gravity, then that object's acceleration will be 9.8 meters per second squared towards Earth. Important, 9.8 is a rounded value. In Excel exams, you must use 9.8 or you will lose marks. So please use 9.8. Do not use 9.81. 9.8 always. In this lesson, we will consider objects that are moving vertically and the only force acting is gravity. This means we ignore air resistance. Therefore, the acceleration of the object experienced will always be 9.8 meters per second towards Earth. Okay, some notes to think about. An object can have positive velocity and negative acceleration. This will mean that the object velocity is getting closer to zero. An object can have negative velocity and positive acceleration. This will mean that the object's velocity is getting closer to zero. An object can have positive velocity and positive acceleration. This will mean that the object velocity is getting further away from zero in the positive direction. An object can have negative velocity and negative acceleration. This will mean that the object's velocity is getting further away from zero in the negative direction. Some people use this deceleration to describe negative acceleration. We will always refer to acceleration as positive and negative and never use deceleration. It's really important that we have defined what direction we consider to be positive and negative. So always label your diagram which side is positive. When considering vertical motion, when the object hits the ground, we say it hits the ground with the velocity. So it always hits the ground with the velocity. Common student misconception is that it hits the ground with velocity equal to zero. It does not, so it will have velocity. Our model stops before the particle acceleration changes due to the impact with the ground. More on this when we get to forces. So basically, do not assume that when it hits the ground, the velocity is zero. Okay, a ball falls off a cliff and lands on a beach 3.2 seconds later. How high is the cliff? So very important that you draw diagrams, right? So it's a ball falling off a cliff, so like this. So this is a positive direction, so double arrow to show positive direction. Now because it's traveling in the same direction as gravity, then acceleration will also be 9.8. So with the double arrow, I always label the acceleration, so 9.8. We know that the ball falls off from rest, I should say. A ball from rest, that's missing here. And we know that we don't know what this is, but we also know it's 3.2 seconds. It takes 3.2 seconds to travel from there to there. Okay, so we have S, U, V, A, and T. So we don't know how high is the cliff, so we're trying to find out what the displacement is. Initial speed is zero because it's from rest. Final velocity, remember, is not zero. When it hits the ground, it's not equal to zero. We do not know what it is, so leave it as a cross. Acceleration is positive 9.8 because it's traveling in the same direction as gravity, so it's positive 9.8. And time is 3.2 seconds. So we have in front of us SUAT. So S is equal to UT. S is equal to UT plus half AT squared. So S is equal to 0 times 3.2 plus half times 9.8 times 3.2 squared. So S is equal to 50.176, which is equal to 50.2. Now, because we weren't given units, I'm just going to assume it's meters. 50.2 meters. Okay, next question. A ball is projected vertically upwards from point X. Okay, point X, which is 7 meters above the ground. Okay, 7 meters above the ground with a speed of 21 meters per second. So it's going to go up and then go down like this. Okay, we are traveling in this direction. So this is the positive direction. That means because it's traveling the opposite direction of gravity, acceleration is negative 9.8. We draw a single arrow to represent the velocity, which is 21, positive 21 in this case. So the velocity can be positive and the acceleration can be negative. It just means it's slowing down. Okay, so we've got that labeled now. So now A, find the greatest height above the ground reached by the ball. So S is equal to, okay, so journey is greatest height above the ground means from X to highest point. That's the part of the journey we're considering. So we're trying to find the greatest height, so that's question mark. Initial speed is 21. What we do know is at the highest speed, velocity is equal to 0. So it's equal to 0. Acceleration is minus 9.8. And time, we don't know. So what we have in front of us is S, U, V, and A, which means V squared is equal to U squared plus 2AS. So 0 squared is equal to 21 squared plus 2 times minus 9.8 times S, which means S is equal to minus 21 squared over 2 times minus 9.8, which means S is equal to 22.5 meters. Now that is this part of the journey. So this is 22.5. We just worked out that is 22.5. But we want the greatest height above the ground reached by the ball. That would be 22.5 plus 7. So greatest height above ground will be equal to 22.5 plus the 7 from X, yeah, below X, which is 29.5 meters. Okay, part B, the time of flight of the ball. So that means from X to ground. So the whole journey. Okay, so again, we have to set up SUVA. Now, because the ball ends up in the negative direction, falling below the point X by 7 meters, the displacement is negative 7. Is below. So remember, positive direction was going up, so going down is negative. So minus 7. Initial speed is 21. Final speed, remember, we don't know the speed at which it hits the floor ever or the ground ever. Acceleration is minus 9.8. And T is what we're looking for, the time of flight. So we have in front of us S, U, A, and T. So S is equal to UT plus half AT squared. Minus 7 is equal to 21t plus half times minus 9.8 times t squared. Minus 7 is equal to 21t minus 4.9 t squared, which means if I take everything to the left-hand side, 4.9 t squared minus 21t minus 7 equals 0. Using the quadratic formula, t will be equal to 21 plus or minus 21 squared minus 4 times 4.9 times minus 7 all over 2 times 4.9, 2 times 4.9, which means t is equal to 4.5965 blah blah blah, or t is equal to negative 0.31079. Now we know time is greater than 0. As t is greater than 0, t must be equal to 4.5965, which means t must be equal to 4.60 seconds. A particle is projected vertically upwards from point O with speed u meters per second. The greatest height reached by the particle is 62.5 meters above O. Okay, so somewhere we have a particle which is projected from O, which means it goes up and then back. We know that because it's moving, whoops. So because it's positive direction up, but acceleration will be negative 9.8 because it's acting in the opposite direction. We know the initial speed is u, and also the initial speed is u, and also the greatest height reached is 62.5. Find the value of u. So to find the value at u, we need to find the journey from O to the maximum point where velocity is equal to 0. So that means A from O to maximum height is, if I set up suvat for that part of the journey, then we know the maximum height was 62.5 meters. We don't know the initial speed, which is what we're trying to find out. We know the final velocity is 0. We know acceleration is minus 9.8. We don't know the time. So we've got S, U, V, and A. So V squared is equal to U squared plus 2AS. 0 squared is equal to U squared plus 2 times minus 9.8 times 62.5. Which means u squared is equal to negative 2 times negative 9.8 times 62.5. U will be square root of all that. Negative will become positive, so 2 times 9.8 times 62.5. U will be equal to 35, and it's meters per second. Part B, the total time for which the particle is 50 meters above above O. So 50 meters is going to be, if I look at that, will be from, imagine if 50 was there, if 50 meters is somewhere here, it's going to be that part of the journey. So what I need to do is from O to 50 meters, I need to set up suvat for that. So the displacement will be 50. The initial speed I know now, which is 35. I don't know the final speed when it reaches 50. I know acceleration is minus 9.8. I'm trying to find the time that it takes to get to 50. So what I do have in front of me is S, U, A, and T. So S is equal to UT plus half AT squared. 50 is equal to 35T plus half times minus 9.8 times T squared. 50 is equal to 35T minus 4.9T squared. Take everything to the left-hand side. 4.9T squared minus 35T plus 50 is equal to 0. T using the quadratic formula is 35 plus or minus 35 squared minus 4 times 4.9 times 50 all over 2 times 4.9. Gives us a value of T is equal to 5.16861, or T is equal to 1.97423, which implies T is equal to 5.17 and T is equal to 1.97. So we know the two times. So if I want to find the time that is above 50, I just have to subtract them. So total time above 50 meters is equal to 5.17 take away 1.97 seconds. So these are seconds, which is equal to 3.2 seconds. Okay, next question. A ball is thrown vertically downwards from a top of a tower with speed 18 meters per second. So it's trapped. This is the positive direction. It's going the same direction of gravity. So acceleration is positive 9.8. The speed is 18 meters per second. It reaches the ground at t equals 1.6 seconds. Find the height of the tower. So height is s. Initial speed is 18. We don't know the speed at when it reaches the ground, so we never know the speed at which it hits the ground. Acceleration is 9.8. The time is 1.6. So what we have in front of us is s, u, a, and t, which means s is equal to ut plus half at squared. S is equal to 18 times 1.6 plus half times 9.8 times 1.6 squared. S is equal to 41.344. So S is equal to 41.3 meters. A ball is projected upwards from a point which is 4 meters above the ground with speed 18. So I know this is 4 meters with speed 18, so 18 going up. It's positive direction, but acceleration is negative 9.8. Fine. I always call the way it travels first positive direction. You can set it up the other way, but I always find a consistent method always works out. Okay. The speed of the ball when it is 15 meters above its point of projection. Okay, so from point of projection to 15 meters. So that would be, I know the displacement is 15, the initial speed is 18. I don't know I'm trying to find the final velocity. The acceleration is minus 9.8. I don't know the time. So S, U, V, and A, which means V squared is equal to U squared plus 2AS. V squared is equal to 18 squared plus 2 times minus 9.8 times 15, which means V is equal to square root of 18 squared plus 2 times minus 9.8 times 15. Which is equal to, V is equal to 5.47722, so on. So V would be equal to 5.48 meters per second. The speed at which the ball hits the ground. Okay, so that means V is from point of projection to ground. So because it lands 4 meters away from the starting point, 4 meters below the starting point, then the displacement is -4. Initial speed is 18. We're trying to find the final speed when it hits the ground. Acceleration is minus 9.8. We don't know what t is. So we've got S, U, V, and A, which means again V squared is equal to U squared plus 2AS. V squared is equal to 18 squared plus 2 times minus 9.8 times minus 4. So V will be equal to square root of 18 squared plus 2 times minus 9.8 times minus 4. V is equal to negative. We're going to take the negative value because remember, if it's traveling up, it's a positive velocity, but if it's traveling down, it's a negative velocity. So it's going to be negative of the square root, which is going to be negative 20.05991, which means the velocity is equal to negative 20.1 meters per second. Therefore, we're asked to find the speed, which is positive. Speed will be equal to 20.1 meters per second. The next question, a particle P is projected vertically upwards from point X. 5 seconds later, P is moving downwards with speed 10 meters per second. So particle P starts from point X, and then it goes, oops, undo. 5 seconds later, P is moving downwards with speed velocity at 10 meters per second. So with the journey we're interested in is 5 seconds after projection. So setting up Subat for that journey. We don't know the displacement. We know the initial, we try to find the initial speed. We know at 5 seconds it's traveling at 10 meters per second. So it's traveling up. So that means acceleration is minus 9.8 and the time is 5 seconds. So what we have is U, V, A, and T, which means V is equal to U plus AT. So 10 is equal to U plus minus 9.8 times 5. So U will be equal to 10 take away minus, it's moving downwards, so that velocity is minus 10. So velocity is minus 10. So be very careful with that. It's moving downwards with the speed. So at t equals 5, somewhere here, it's moving down, so it's minus 10, because originally moving up was positive. So we end up getting U is equal to minus 10 take away minus 9.8 times 5, which means U is equal to 39 meters per second. V is the greatest height above X attained by P during its motion. So it's going to be from projection to highest point. So at the highest point, we know velocity is equal to 0. So we're trying to find the highest point, so it's displacement. Initial speed is 39. Final speed is 0. Acceleration is minus 9.8. T, we don't know. So we know V squared is equal to U squared plus 2AS. So 0 squared is equal to 39 squared plus 2 times minus 9.8 times S. So S will be equal to minus 39 squared over 2 times minus 9.8. S is equal to 77.60204, which means S is equal to 78 meters to two significant figures. At this point, I should say, because 9.8 has been rounded to two significant figures, normally in your answer, you should round to two significant figures always. What I do is I try to write my full answer and then round it. So just in case I make a mistake, because I've got my working out there, I'll ensure I get my accuracy mark anyway, because I've written my full answer anyway. Okay, so always round to two significant figures because 9.8 has been rounded to two significant figures. Okay, next question. A stone is thrown vertically upwards from a point which is 3 meters above the ground with a speed of 16 meters per second. And 3 meters above the ground. It's thrown upwards, so up being positive, so acceleration is minus 9.8 and the speed is 16, initial speed. So A, find the time of flight of the stone. Projection to ground, because the time of flight for the whole journey. So because it lands 3 meters below where it started, displacement is minus 3. Initial speed is 16. Final speed we don't know. Acceleration is minus 9.8. And time is what we're trying to find out. We've got S, U, A, and T. S is equal to UT plus half AT squared. So minus 3 is equal to 16 times T plus half times minus 9.8 times T squared. Minus 3 is equal to 16T minus 4.9t squared. If I take everything to the left-hand side, 4.9t squared minus 16t minus 3 is equal to 0, which means t is equal to, using quadratic formula, is 16 plus or minus 16 squared minus 4 times 4.9 times minus 3, all over 2 times 4.9, which gives a value of t is equal to 3.44312, or t is equal to negative 0.17781. As t is greater than 0, t must be equal to 3.44312, which means t is equal to 3.4 seconds. The total distance travelled by the stone. So what I need to do is find first up to the highest point. So if I find out the journey from here to here, then I know the distance travelled from there. So at the highest point we know b is equal to 0. So projection to highest point. S, U, V, A, and T. The S is what we're trying to find out. Initial speed is 16. Final velocity at the highest point is 0. Acceleration is minus 9.8. And T we don't know. So we've got S, U, V, A. So that means V squared is equal to U squared plus 2AS. So 0 squared is equal to 16 squared plus 2 times minus 9.8 times S, which means S is equal to negative 16 squared over 2 times minus 9.8, which gives a value of S is equal to 13.06122, so on. Now we're trying to find the total distance travelled. So total distance travelled will be 2 times this number. It's going to go there and it's going to come back, which is the same amount, and then plus 3. So it's going to be 2 lots of what I just worked out, which is 13.06122, plus the 3 from obviously the point of projection to the ground, which works out to be 29.1244, which is 29 meters to 2 significant figures. A particle projected vertically upwards with a speed of 24.5 meters per second. Find the total time for which it is 21 meters or more above its point of projection. So it's traveling up and then down. We've got it traveling up first, a positive up, going up. Acceleration is minus 9.8. Let's redraw this. Okay, so traveling up to positive up. Acceleration is minus 9.8. Initial speed is 24.5. And we're trying to work out how long, if it's above, if this is 21 meters, how long it's above 21. So we're trying to find out basically the time between there and there. So if we're doing SUVAT for this, displacement is 21. Initial speed is 24.5. Final speed we don't know. Acceleration is minus 9.8. T is equal to question mark. So S, U, A, and T. S is equal to UT plus half AT squared. 21 is equal to 24.5T plus half times minus 9.8 times T squared. 21 is equal to 24.5T minus 4.9T squared. Take it all to the left-hand side. 4.9T squared minus 24.5T plus 21 equals 0. T is equal to 24.5 plus or minus 24.5 squared minus 4 times 4.9 times 21 all over 2 times 4.9, which means t is equal to 3.90152 and t is equal to 1.09847. So time in between, total time above would be above 21 meters would be equal to 3.90152 take away 1.09847, which is equal to 2.80305, which when rounded to two significant figures is equal to 2.8 seconds. Now we need to think of a second journey that involves u, which is obviously going to be the whole journey, so from P to R. So if we set up that from P to R, then we know that from P to R, the displacement is 165 meters. Initial speed is still u. Final velocity we don't care about. Acceleration is a. And the time it takes to do the whole journey is 6 seconds. So we've still got S, U, A, and T. So S is equal to UT plus half AT squared, which means 165 is equal to U times 6 plus half A times 6 squared, which becomes 165 is equal to 6U plus 18A, and that is equation 2. So now we're trying to solve it simultaneously. Let's times equation 1 by 3, then we end up getting 135 is equal to 6u plus 6a, and second equation is 165 is equal to 6u plus 18a. So let's call this equation 3 and equation 4. And if I do 4 take away 3, then I end up with 165 take away 135 is 30 is equal to 18a take away 6a, which is 12a. So a is equal to 30 over 12, which means a is equal to 2.5 meters per second squared. And then using 1, we get 45 is equal to 2u plus 2 times 2.5, because a is just 2.5. So that means 45 is equal to 2u plus 5. So 2u is equal to 40, which means u is equal to 20 meters per second. 40 divided by 2 is 20. So u is equal to 20 meters per second, and a is equal to 2.5 meters per second squared. Last question. A stone is projected vertically upwards from a point A with a speed of u meters per second. After projection, the stone moves freely under gravity until it returns to A. So from A to A, the time between the instant that the stone is projected and the instant that it returns to A is equal to 3 4/7 seconds. So if speed is u, this moving up, so acceleration is minus 9.8. So 8. Modeling a stone as a particle show that u is equal to 17.5. So this is the whole journey from A. So A to A. If I set up that from A to A, then displacement is 0, initial speed is u, final speed, because it's metrical, it will be minus u. Acceleration is minus 9.8, and time is equal to 3 4/7. So I've got everything here, so I can use any equation of motion. So I'm going to use v is equal to u plus at. So that means v is minus u is equal to u plus minus 9.8 times 3 4/7, which means I get minus 2u is equal to minus 9.8 times 3 4/7. So u will be equal to, in my calculator, I need to put minus 9.8 times 3 4/7 all over minus 2. which gives me a value of 17.5 meters per second. B. Find the greatest height above A reached by the stone. So that means I need to look at when it gets to the maximum point. So A to maximum height. So if I do suvat for that, and we're trying to find the maximum height, which is this displacement. Initial speed is 17.5. Final speed is 0. Acceleration is minus 9.8. And time we don't know. So we've got S, U, V, and A. So V squared is equal to U squared plus 2AS. 0 squared is equal to 17.5 squared plus 2 times minus 9.8 times S. So S will be equal to negative 17.5 squared over 2 times minus 9.8, which means if we put this into a calculator, we end up getting 15.625 meters. C is find the length of time for which the stone is at least 6 3/5 above A. So somewhere around here is 6 3/5. So that means for part C is from A to 6 3/5 above A. So displacement will be 6 3/5, which is 6.6. I'm just going to write 6.6. Initial speed we worked out is 17.5. Final speed we don't know. Acceleration is minus 9.8. And T is what we're trying to figure out. So we've got S, U, A, and T. So S is equal to UT plus half AT squared. 6.6 is equal to 17.5 T plus half times minus 9.8 times T squared. 6.6 is equal to 17.5 T minus 4.9 T squared. If I rearrange it to the left hand side, I get 4.9 T squared minus 17.5 T plus 6.6 equals 0. The quadratic formula, I get T is equal to 17.5 plus or minus 17.5 squared minus 4 times 4.9 times 6.6 all over 2 times 4.9, which gives me a T value of 3.1428, and T is equal to 0.4287. So time in between, if I find the length of time for which the stone is at least 6 3/6, so time stone is at least 6.6 meters above A is equal to 3.14285, take away 0.42857, which gives me a value of 2.71428. So I'll round it to two significant figures, 2.7 seconds.